Welcome back to Geometry! Chapter 5, Section 5 in this book, Inequalities in One Triangle. So, here I have a triangle, and this is the largest angle, and so the side across from it will be the longest side. Notice how I said hand. You have a hand that can make triangles, and you can tell that the size of this side of this triangle is controlled by the hinge right there. You open your hand bigger, this side is bigger. You make your hand smaller, that side is smaller. So you can always remember this one because you know this is true if you make triangles with your hand. You're going, I never made triangles with my hand. Well, now you can. Everybody get out your hand and think about it, okay? So the smallest angle is across from the smallest side. All right? Now, so this is a theorem. Pretty easy. The theorem says if side 1 is greater than side 2, then the angle across from side 1 is greater than the angle across from side 2. The angle across from a side controls how big it is. So if the side is bigger, then the angle across from it is bigger. If the side is smaller, the angle across from it is smaller. The angle across from a side controls how big the side is. Okay? Also, another part of this theorem, if angle 1 is bigger than angle 2, then the side opposite of angle 1 is bigger than the side opposite of angle 2. It's the same thing, they're just saying it the same way. One is starting with the angle, the other one's starting with the side. Either way, the angle and the side across from them are connected. The angle controls how big the side is. I'm looking at you really intently, so you will get this idea. Alright, so here's a problem. So we have these angles, 45, 135. Don't really look at the drawing because that's not really 100. Okay, just pretend. Alright, so let's tell the angles from least to greatest. Well, the least is G. Angle G is less, angles and less look a lot alike, but I'll say the word and you'll know which one I'm writing, is less than angle H. Well, here, we'll do just the letters and not the angles. G is less than H, which is less than J. So now say the sides from least to greatest. The side across from G is HJ. So the small, that's a terrible H. Let's start over there. The smallest side is going to be HJ. There, that's better. Is less than the side across from 45, which is JG. So JG is next, which is less than the biggest side, which is HG. Okay? Here's another triangle, and this 8 is the length of QR. QP is 5, and PR is 7. So let's do the angles in order from least to greatest. Well, the smallest angle will be the one across from the smallest number, so it's R. R is less, and then the next one, the one in the middle is 7, so the angle across from it is Q, and the biggest is 8, and the angle across from it is P. Now let's do the sides in order of least to greatest. That's pretty easy. QP is less than PR, which is less than QR. Done! Not too bad. Okay, here's our next one. The exterior angles inequality theorem. That's an exterior angle. Remember, it's an angle. If you continue a triangle line straight, it makes an angle. So angle 1. This is the theorem. Angle 1 is greater than angle A. Angle 1 is greater than angle B. So what the theorem says is, the two angles that are not linear pairs with the exterior angle are less than the exterior angle. Now, it's not this one, it's these other two. These other two are going to be less than that exterior angle. Okay? Now, the next one is the triangle, the question, will it triangle? If y'all ever watch Rhett and Link, they'll do things like, you know, will it taco or whatever? Well, we're going to say, will it triangle? Okay, and it turns out that not all three sides can be a triangle. Here we have a side that's 5, a side that's 2, and a side that's 2. It will not make a triangle because these two won't meet. If they try to reach for each other, if you think back again of these as hinges, and you're bending them down so that they could meet, they would just collapse right there. So it would be like if you take your hands, and this is the side, and these are the little bits, you can't make them touch without bending that right there. This stick is too long for those. Now the funny thing about this is later on in the book, they will forget this idea of will it triangle, and they will do math. They'll give you a problem with a triangle that doesn't really make a triangle. And my son Eli was excellent. They would try to give it some problem later, and he'd go, nope, it's not a triangle. It won't triangle. And of course I'd forget, and I'd be doing the math. I'd be so excited to do the problem that I'd forget to think, will it triangle? And if the answer is no, then you don't have to do the rest of the problem. So how about this one? 5, 3, and 2. Will it triangle? What do you think? No. What would happen if these swung down, they would end up being flat. Can you sort of imagine that? They would swing all the way down and it would be completely flat. And to be a triangle, it's not just two parallel lines. It has to be a tent. It has to poke up. So, will 4 and 2 make a triangle? Yes, they will. And the reason why is because they're more than 5. The other two sides added together have to be bigger than the hypotenuse. So, triangle inequality theorem. The sum of any two sides is more than the third side. So, the two added up have to be bigger than the other side. So, here I have a triangle. Side 1 is 10, side 2 is 14. What can side 3 be? There's really two answers here. If 14 is the hypotenuse, side 3 needs to be more than 10 plus 4 is 14. So x would have to be greater than 4 if 14 is the hypotenuse. If our unknown side is the hypotenuse, it has to be bigger than 10 and 14 added together. So it would have to be bigger than 24. So like not even like 4.1. We need to, really go with something like 5, 6, 7, and 25, 26, 27, and then we could get a triangle. All right? I think this is real interesting and fun and just logical because everybody has a hand and you can think about that. All right? So math is great. See you next time.